Hey guys, it's Miss Delcambre. So today is Tuesday, November the 17th, and here's a rundown of our day. So there's Harry, Hazel, the squirrel just looking at us. You'll need your journal, glue, pencil, a highlighter, and your notes on 14.2. So make sure that your 14.1 Google Slides and Google Form is turned in. So make sure you get that done. We're going to go into our 14.2 notes, which is independent and dependent variables and tables and graphs. And then we're going to kind of get started on our homework. So let's go. All right, so here's our notes that we have. So today is the 17th, so 11/17. I'm just going to cross this out, 2020. And I'm going to first, before I start on this, talk more about independent and dependent variables. Okay, so if you read this paragraph, it says many real-world situations involve two variable quantities in which one quantity depends on the other. The quantity that depends on the other is called the dependent variable, and the quantity it depends on, so the one that's dependent on something, is dependent on the independent variable. Okay, so I want us to turn our page over, and we're going to make a T-chart, and we're going to compare independent and dependent variables. Okay, I'm going to make a big T right here. On the top, I'm writing independent. On the other side, I'm writing dependent. Okay, when I'm talking about my independent, this is the one that's in control. This is the one that makes the rules. You do something to the independent to get the dependent. Okay, and the dependent depends on that independent. Okay, in math, your independent will always be X. Will always be X. And your dependent will always be Y. It's just the way it is. Just the way it is. X is always the independent. Y is always the dependent. Because when you set it up with your equations with Y equals mx plus b, or Y equals, I believe it's ax or x plus a, your independent is always X, your dependent is Y. So when I'm looking at my independent variables, those are the variables that can stand alone. So it stands alone. Okay, this is also called your input. And when we're talking about our independent variables, like on a graph, this is located at the bottom of a graph, which is your X. Okay? Now your dependent, on the other hand, cannot stand alone. This is what we call our outcome, or our answer. Okay? It's not our input, but it's our output. Kind of like the function tables that we've been dealing with on our builder. You have your input, which was X. Your output is Y, is your Y. And it's not located at the bottom of the graph. It's located at the side of a graph. Which is, again, your Y-axis. Okay, we're going to talk about some things about independent and dependent. And not related to math right now, but let's think of some real-world examples. And one of the real-world examples that we talked about in class, that's our independent variable, is what's going on in the world, is our COVID numbers. Okay? This is an independent variable. It's in control. It tells us it dictates what's going on in the world. Okay? What goes on in the world depends on our COVID numbers. An example. So our mask mandates. Depended on our COVID numbers. Back in March, April, and May, when COVID numbers were down, we didn't have mask mandates. But when COVID numbers rose, states implemented the mask mandates. Okay? Another thing, when COVID started, when the numbers started to increase, we had isolation and lockdown. Some cities were locked down. Actually, right now, there are some cities are locked down for 30 days. Okay? The only essentials are out, but everybody's supposed to be stay at home, or, not locked down. Maybe a stay at home order would have been nicer to write. But COVID numbers tell you if you're going to have isolation or the city's going to be locked down or not. Another thing that happened because of COVID numbers increased is you had restaurant closures and restaurant and salon closures. So when they closed, that's because of COVID numbers when were increasing. They didn't know how it was spreading, so that was one of the results. Okay, once the numbers kind of steadied off and we were seeing a good trend, that's when they started opening back up the restaurants and the hair salons and the nail salons. Another thing, when we first started COVID, the numbers started increasing. They saw that there was a problem that was in control. What was one of the results was we had school closures and virtual learning. All right, so do you see how many, we have a lot of effects for one thing. So our one thing, which is our independent variable, dictated all of these things. These all depend on what our COVID numbers were. Okay, let's get off of that subject, okay? Let's talk about like shopping and Black Friday shopping. All right, so with Black Friday shopping, lots of stores do some sales. And last year, there were lots of people who lined up in lines waiting to get those sales. So we're going to talk about that. We're going to talk about the number of people in line. And you could think of this as shopping. You could think of it as one of the new movies that came out, like the Avengers movies. Okay, lots of people lined up in line to see the movie. Okay, that's my independent variable. Well, what depends on that? Well, how long do they wait in line? Okay, if there were a lot of people in line, you're going to have a long wait. If you don't have that many people in line, you're not going to have a long wait. So the number of people in line dictated how long we were going to wait. Okay, another independent variable that we're going to talk about is the weather. The weather is very independent. It dictates a lot of stuff. There's lots of things that depend on the weather. Okay, here at school, recess depends on the weather. Okay, if it's raining, we're canceling recess. If we had the tropical or the Hurricane Laura that was coming through, that thought it was going to come into Texas, but it made a turn at the last minute and hit Louisiana. That was weather. And what happened there is it canceled school. School was canceled. Okay, if it's raining outside, PE is affected. Say coach made an outside activity and then it started to rain, so now everything has to go inside. So PE. Another thing with weather is soccer games. Soccer and football games. Well, let's throw baseball in there. When it's raining and say there's lightning going around, they're going to cancel that soccer, football, and baseball games. Right? Another thing that depends on the weather is how a person is driving. Now, these are just some of them. They're not all of them. But you know that driving depends on, well, how the weather is going to be. If it's raining and nasty and overcast and you can't see in front of you, you're probably going to be driving a lot slower and more cautious. However, if the weather's nice, you're probably going to be driving the speed limit. All right, and again, we're going to do one more thing with independent variable, and we're going to think about the holiday that's coming up, and we're going to talk about turkey. So the weight of a turkey. Now, the weight of a turkey, that is independent, and there are some definite things that depend on the weight of a turkey. So, cooking turkeys have different wait times. Cooking times. Cooking turkeys to have different cooking. That made no sense whatsoever. Okay. Turkeys that have different weights have different cook times. So cook time is our dependent variable. It depends on how big the turkey is. Normally they say it's about like 20 minutes per pound to cook a turkey. 20, 25, it depends on who you talk to. So if I had a 10-pound turkey, we're looking at 200 minutes. Let's just round that off. So that's roughly over an hour and a half. No, actually over 2.5 hours, sorry. But if you have a 40-pound turkey, are you going to want to cook your 40-pound turkey just 2.5 hours? No. So the weight of the turkey depends on the cook time. The bigger the turkey, the longer it needs to cook. All right. Another one is the cost of the turkey. So normally the larger the turkey you have, the more it's going to cost. The smaller the turkey you have, the least amount it's going to cost. And finally, another thing, well, again, with the weight of the turkey and how big you have it, is the amount of people you can feed. Can feed. So if I had a 10-pound turkey and I had 10 people over, I could probably feed them all with my 10-pound turkey. Now, if I had 50 people over with my 10-pound turkey, I would probably be stretching that turkey. Everybody wouldn't be getting a hearty helping. They may be getting a little sliver of turkey. So you want to make sure that the weight of the turkey and the amount of people, you'll have enough turkey to feed the amount of people. Okay, so that's a dependent variable. This is your independent. Okay, let's turn our page over. So I have a real world situation that the variables could represent. Describe the relationship between the independent and dependent variables. So we talked about this in class. We talked about some collections, like what do you collect? We had people that collected rocks. We had people that collected Pokemon cards. We had people who collected dolls, stuffed animals, blankets, lots of different things people collected. But I want to talk about rocks. I used to collect rocks too. So we're going to talk, and we're going to look at this table here, make a word problem. So we used Serena in our last class. So Serena received 15 rocks from her mother. Okay. Say her mom went to the Grand Canyon, picked 15 rocks up and said, these are beautiful rocks. I'm bringing them home. 15 rocks from her mother. So each month, she adds one more rock to her collection. Okay, there's my word problem right there. Okay, so if I'm looking at this, I'm looking at my X and I'm looking at my Y. So 0, 15. Well, 15 is what I started with. These are my rocks. These numbers represent my rocks, making X represent my months. So starting off at 0 months, before she even started, she had 15 rocks. So how did I go from 0 to 15? Well, I added 15. How did I go from 1 to 16? I add 15. You see that each time you're adding 15 to your X to get Y. So my months, what am I doing to my months to get my rocks? So I'm adding 15. So my months is my independent variable. Okay, making my dependent variable my rocks. So I can look at this and say, well, the rocks is 15 more than the months. So the value of Y, because that's rocks, is 15 more than X. Okay? And we can look and we can say that this is an additive relationship, because I'm adding prop to X to get the Y. So if I'm going to draw this right here, draw a graph. It's very easy to draw a graph if I could. There we go. I'm going to draw a big OL. I draw an arrow at one end and an arrow at the other end. Again, remember that we talked about X is at the bottom of the graph, Y is on the side of the graph. So bottom, side. Okay, well, looking here at the top, I'm looking at X and Y. All right, it was 0, 15, 1, 16, 2, 17, 3, 18. So these are my ordered pairs. So again, my X, which is down here, is my months. And my Y, which is here, is my rocks. All right, I started off with 0, and 0 on a number line is going to be right here where they intersect, which is 0, 1, 2, 3. And then I need to make sure 15's on here. So what I'm going to do is I'm going to put like a little Z right there, and that breaks up this number line, meaning, hey, there's numbers right here, but I'm starting off at 15. So I'm going to go 15, 16, 17, 18, and I'm just going to have enough room to put 19. So if I'm looking at my number line, or I'm looking at my graph, my first order pair is 0, 15. So I'm going to stay at 0. I'm going to put my dot on the 15 right there on the Y axis. So my next one, I need to go over to 1 and then up to 16. The second one is, the third dot is over 2 up 17, over to 2 up to 17. Final one, I'm going to go over to 3 up to 18. And then again, all the time when you're graphing, you make sure your numbers are right, your dots are plotted, And then you're going to draw a line through and make sure that your arrow is there to show that it's a continuous line that continues. It can continue. All right. So that does it for our notes for today. All right. And tomorrow we're going to be writing equations from these tables and graphs, which basically is kind of like this. We're figuring out, well, what kind of relationship is it going to be, and write an equation using X and Y and how those relationships work together. All right. So that's it for today. Your homework. Oh, I'm sorry. Your homework is something I forgot to go over. Give me a minute. Dun, dun, dun. Your homework is right here. Let's go over some of these questions. Okay. So a food worker earns $12 per hour. How much money does the worker earn on a shift of 8 hours? So if I'm looking here, I'm comparing two things. I'm comparing money and hours. Okay, so if I just did a table and they worked 1 hour, that person would make $12. If they worked 5 hours, they would make $60. So my independent variable, which one can stand alone, is hours, because hours dictates how much money you have. So hours dictate how much money you have. Okay. Number 2, a large 2-topping pizza costs $2 more than a 3-topping medium pizza. Okay. So what we did in class is we talked about places like Little Caesars. Okay, the medium and the large. So their medium, it doesn't tell me what, so let's just say it's $5. And a large would be what? Well, a large 2-topping is $2 more than a medium 3-topping. Well, if the medium's $5, I add 2, the large would be $7. So we go to no one huts the Pizza Hut. How does it go? No one out pizzas the hut. Pizza Hut. So the Pizza Hut medium, let's say, is $10. But then the large costs $2 more than whatever the medium costs, which would be $12. So the independent variable would be your medium, because your large depends on how much your medium costs you. Now I want you to look at this one. I want to make a quick little edit. I want this to be 100. Okay, just so that you can understand it a little better. So you're not like, what in the world does that mean? Okay, so we're talking about the electric current produced on a solar cell in different amounts of sunlight, which is a light intensity. So think of this as sunlight. This is sunlight. Okay. So what is the dependent variable? What is the independent variable? How can you predict what the current will be with the absence of sunlight? And what would you predict that the current would be with a light intensity of 1,000? So if I continue that table, what would this number be? What would the current be? So right now we're going to stop right there on 1 through 6, because that is your homework. And if you have any questions, please feel free to email me. If not, I will see you later, and have a great day. Bye.